Welcome back as we use example 7, module 2, investigation 4 in place of a Monday lecture and group setting. Let's read number 7. Alan and Alissa are attempting to find each other in a crowded mall. They finally spot each other near the food court, at which point they are 140 feet apart. Alan and Alissa begin walking towards each other. Alan travels at a constant rate of 5 feet per second, and Alissa travels at a constant rate of 4 feet per second. Part A. What quantities are varying in this context? What quantities are constant? Be sure to include units for each quantity. Draw a diagram of the situation if it's useful. Maybe this would be a good time to pause and think on this. Okay, the author would suggest there are some changing quantities. Time is elapsing. The time since Alan and Alissa spotted one another can be measured in seconds. The distance in feet that Alan has traveled. Then there's another measurement, another changing quantity, distance in feet, that Alissa has traveled. And then I notice there was a constant in the problem. When they spot each other, they're 140 feet apart. So to me, another relevant changing quantity would be the distance in feet between Alan and Alissa. And I think this is where we're going. Okay, now the constant quantities given, there was the speed of Alan, that was 5 feet per second, and the speed of Alissa, 4 feet per second, and somewhere we need to add that 140 feet apart when they spotted each other. Okay, let's switch this and see what, the author would next suggest that we just investigate the different values of some of these varying quantities. When it's 0 seconds since the two people spotted each other, Alan, he hasn't traveled any amount of feet since he spotted Alissa. Alissa has not traveled since she spotted Alan, if 0 seconds have elapsed. And their distance, which is going to be changing, is 140 feet apart right when they spot each other. We can fill in values because we know for every second Alan travels 5 feet, whereas Alissa travels 4. We can fill in distance for Alan that he has traveled, distance for Alissa. Now they're closer together. They are 131 feet apart. When we change from n equals 1 to n equals 2, then we would add 5 feet that Alan has traveled. We'd only add 4 feet to Alissa's traveled distance, since she's a little bit slower. But we're going to take off another 9 feet from how far they are apart. And you could take your time and fill in the rest of this chart. Maybe pause my chart and then hit it again when you're ready to go. And we'll fill those in. Oops, I could go back, fill those in again. We're going to subtract 9 from 68. Oh, it jumped. Oh, I didn't see that. We started jumping 2 feet. Alan traveled 10. Alissa traveled 8. And they dropped 18 feet. So don't get sucked into that error I made, because the change in n becomes 2 there in the chart. Okay, part C. Now for each second that passes, since Alan and Alissa spotted each other, how many feet closer are Alan and Alissa? Okay, well, we saw when there was a change in time of 1 second, they drew 9 feet closer together. Now the author explains this way. Alan's traveling toward Alissa at a constant rate of 5 feet each second. Alissa is traveling toward Alan at 4 feet each second. And that's a total decrease in distance of 9 feet each second that they are apart. Part D. This is where we go from numerical data and lots of values of the variables to something more abstract where we're going to relate the quantities. And the author asks us in Part D to define formulas to relate each of the following quantities. And of course we'll define the variables. So just part 1, we're going to write a formula for Alan's distance traveled in feet in terms of the number of elapsed seconds since he spotted Alissa. Okay, so we needed to define two variables. Okay, let's let t represent the time elapsed in seconds since they spotted each other. And the author's going to use subscripts like this little one that falls below the d. We call that a subscript, or sometimes I joke that's the luggage tag. So we know that that goes with the first person, Alan. And his distance traveled, we have this constant rate of 5 feet per second. But we want to make mention that the author goes straight to d1 equals 5t instead of delta d1 equals delta. Oh, did I miss it? Let me go back and then forward a little bit. Okay, you may want to pause here and think about why d1 equals 5t. Hint, the initial value of d is 0, the initial value of t is 0, so any change in d1 from 0 is still d1, and any change in t from t equals 0 is just t. Okay, you're going to see part 2 of d, Alissa's distance traveled. We use the same variable t, since that's how many seconds elapse since they spot each other. But we're going to use a different variable, d2. We could have used a capital D, we could have used a different letter, but the author chose a subscript 2 because this is the second distance. And you'll see a similar representation of how the two variables change with respect to one another. d2 in terms of t is d2 equals 4 times t. And we didn't have to talk about change in d directly because any further distance, the change in d2 is going to be the final distance minus 0. And time is elapsing since 0, so any final time minus initial time 0 would just be t. Okay, now if you read part 3 carefully, now we're going to what I had noticed as maybe the first question. But the distance between Alan and Alissa is changing as they walk toward each other. So we're going to write a formula for distance between Alan and Alissa in feet in terms of the number of elapsed seconds since they spotted each other. So we have the same variable t. They spot each other when t equals 0. And now d is the distance between Alan and Alissa. And we know that when t is 0, d is 140. That comes from the problem. Okay, so stare at this answer here a little bit, and we'll try to make more sense of it. But if you check back, and I think I can flip through this, I'm going to go back to slide 37. Each distance between them is going to be 9t subtracted from 140. Okay, so if we fill in this chart again, 140 minus 9 times 1 is 131. 140 minus 9 times 2 is 122. 140 feet minus 9 times 4 would be 140 minus 36, or 104, and so on. You can pause there maybe and check. And I'm now flipping back to where we were, where you can check this formula. Okay. Let's see what our next slide is. Oh, and this is a good one. So let's let this be something for you to think about. To finish up your notes, because your instructor may have asked you to place notes from this explanation in the Dropbox for your course, but I want you to work this out. Use that formula back on the previous slide where d equals 140 minus 9t, and determine how many seconds it will take for Alan and Alissa to reach one another. Okay, appreciate your attention. Thank you.